Well, hello there. This is our whiteboard drawing of 100N circulating raw water system. This plant called it raw water. They had filtered water and demin water. Different plants call it different names. This came in off the river. First thing, we had a trash rack taking large debris out. Then we had 6 traveling screens. These were set up to run on high DP, and also every shift the operator would run the screens. You're listening for noises and make sure the nozzles weren't plugged. The debris that was blown off went down a trough, a little strainer here, and then it went out to the river. It's called the fish line because I always kept water running down this in case any little fingerlings got caught. I'd flush them back to the river. This was the screen wash pump. This would run when you want to rush the screens. It took its suction off the discharge of the circulating raw water pumps. Off this line we had a shaft pre-lube water for the circulating raw water pumps, and also low lift diesel pump jacket water coolers came off of this. This ensured there's always a supply of water. These pumps, like 1 and 3, were fed off A bus, 2 and 4 were B bus in-house power. So if you lost outside power, you still had cooling water to get the plant shut down safely. Here's where your circulating raw water pumps. They were 3,500 horsepower synchronous motor. I ran 13.8 kV and ran 3,600 RPM. Since they were synchronous, they held that speed. One advantage to synchronous motors, they hold this speed, and they also can be used to balance the plant power factor. The pump had an exciter on top, and it had 2 air coolers, 1 on each side. Plus there's cooling water for the thrust bearing oil. There's a lot of load on the thrust bearings on these because the weight of the water being pulled up is being the counterforce here. The exciter also had a water cooled air cooling on it. These motors were good for about 200 starts, and they come pretty close to that. I guess it was the high corona from starting it and just the starting conditions. One went like 202, another one made it like 198. Downstream of these, the discharge on these pumps were hydraulic driven with a hydropack. And then you had dual check valves down the pit out here to prevent any backflow. The low lift diesel pumps, they were GMC 16278A. These were used on quite a few ships. They were a pretty common marine engine. Really good, durable engine. We had 2 GMC 16278A pumps and 1 GMC 12-cylinder 278A diesel pump. From here I went to a right angle gear drive in the pump. So this was ran time the reactor scrammed, these would start. And they provided water to the silo, ERW tank, and the fog sprays. That was just part of the scram circuit. These pumps were started with 600 psi air. It was only injected into a few cylinders. I believe they used 4 cylinders on it. Possibly could have used a few more, but high pressure air rolled these over and started them. So as a good starting system, you always had backup air, a lot of accumulators. This plant was designed to abandon it and it'd run itself for emergency shutdown. The engines, 1,600 horsepower, ran 750 RPM max. 450 was the idle RPM. Basically 900 degrees was maximum exhaust temperature. Didn't want more than 200 degrees cylinder differential. Interesting fact, it was 1,050 psi when they fired. I think compression was about 450 to 500. This was important. The differential cylinder told you what the engine was doing. If you have bad injectors, something not set up right, you'll have the exhaust temperatures will vary quite a bit. Usually they're pretty close, within 50 degrees. They were set up pretty good. Every month we had to run these engines. You'd put it in pull-up stop, open the little petcocks in every cylinder, then roll it over. And that would let you know the petcocks went to the cylinder, so blow out any vapor or water, if you had a cracked line or any problem with it. We had guys start the engine with the petcocks open and throw a lot of fire out because it's coming right out of the combustion chamber. And if you ever left one in pull-up stop, it was pretty serious because the engine wouldn't start during the scram. But these were PM'd every month. They had like a 10-day supply of fuel to run, so if something did happen, they could run themselves for extended periods of time. After this part, we have some drawings and a few pictures of this to make this a little bit more clear. This just kind of shows the basic flow path through this part of it. And we will continue on this raw water flow downstream the dual checks through the rest of the plant. Okay, these are the drawings we found, the various pieces of equipment from our whiteboard. This makes it a little bit clearer. This is one of the traveling screens. Water flows this way through it. The screens were a 15 M&M gauge wire. Direction of flow is this way through the screen. The nozzle sat in here, and they'd blow the trash off the screens into a trough that disposed of it. The motor was a 2-speed motor. Usually it'd run low speed, high DP across the screen. It'd kick into high speed. These had electric heaters on them for winter operation. Have your chain tightener. Inspection doors. To grease them, you'd open this door and use a grease gun, and every one of these little rollers come by, you'd hit it with grease. They seem to work pretty well, not a lot of problems with them. Big problem with screens is letting too much debris build up on them. You get too much of a DP, there's not enough power for them to drive. So some plants can have problems with excessive DP and the screens won't go. Every shift the operators would run these. Back then we worked 8-hour shifts instead of the 12-hour shifts. Big thing was to check nozzles, make sure they weren't plugged. Otherwise you'd carry debris over and dump it. This is the cross section of the circulating water pump bay. Had a bar screen or trash rack. Here's how the screen sat. Fish ports for the fish to swim and get out of here. Screen sat here. Had inner floodgate to balance the flows across this. This was your circulating water pump. 66-inch ID pipe going down to the pump pit. I think these sat 4 to 6 feet off the bottom. It had a 66-inch outlet line. This was the hydro pack for the circulating raw water pumps. Used hydraulic pressure to run the discharge valve. One hydro pack fed 2 pumps. Their hydraulic motor, you had accumulators to maintain pressure on the system. When the pumps weren't running, pumps just run, maintain pressure, build up pressure. This is kind of the control setup for the valves. This is drawing we found the USS Slater. Go to the website, they have some really good stuff on it. These are the same engines we use. They're marine diesel engines. They had good pictures. They're very similar. These had little petcocks right in here. You would open, and then you'd put them pull up stop, crank it over and blow any moisture or anything out of the cylinders. You tell if you had a cracked liner or problems. Used high pressure air to start them. We used 600 psi air. One problem you could have is the solenoid sticks open after they start, dump cold air into the engine and cause liner damage. One thing about using compressed air to start them, you can store a lot of air in a reservoir for starting them, and you can also use bottled nitrogen or compressed air to ensure that you got them started. Had a blower on one end. Here's some other drawings of the internals of it. If you're interested in these, go to their website. They have some good pictures from the GM manual. Same engine, they are widely used in a lot of equipment. Okay, this is the low lift diesel pump drive. Got a traveling screen on that also. Here was the pump for the diesel engine. Had a right angle gear drives. Had the diesel engine, exhaust silencers on it. You had a jacket water cooler and a lube oil cooler on it. Screen wash pump set, same building on the south end. Discharge pipe. This took jacket water for the cooler. It also come off the circ water pumps too. This is the cooling system for the diesel engine. All 8 diesels were set up the same. The jacket water would come off the top 4-inch line. It went down to a 3-way thermostat control valve. For startup, the jacket water would go to the lube oil cooler and try and heat the oil up, get the oil up to temperature. As this water oil got warmer, then it'd send the water to the jacket water cooler. It went to the jacket water cooler and then it'd go to the lube oil cooler. Then when the lube oil a little bit warmer than jacket water, this system seemed to work pretty good. From there it went to the jacket water pump, back to the diesel engine. This was fed off the pump discharge, usually. From here it also had water, went to the right angle gear drive cooler, jacket water cooler, and discharged. Had an expansion tank on the suction to the jacket water pump. This used filtered water. I believe we added some different anti-corrosion chemicals to it. So this maintained the level on the system, and also as the water heated up, it would expand, and it's kind of like a little jacket water tank on a car radiator. This was the control mechanism. I believe we had a Woodward governor on this. There wasn't any speed droop on these engines, and it was full load. Speed droop was used for power generation, so if the diesel hit full load, it'd start backing off on RPM a little bit, then the other engine would pick up the load. These were driving pumps, so they just run full out if they needed to. This was the manual control. It kind of sat on the side of the engines, I believe. You'd pull all the way up to pull up stop. This would shut off the fuel rack to the engine, so you could roll the engine over for maintenance or performing PMs, preventive maintenance on the engine. One major problem you'd have, pull up stop and forget about and leave it, then the reactor scram, the diesel wouldn't start, so that was a major issue. This was the manual control of the engine basically. Usually you'd start and let the governor run it. They had recircs off the pump. I believe 450 RPM was the lowest RPM we'd run these, just for the pumping requirements. 750 was maximum load. It seemed to be a pretty good engine. They leaked a lot of oil. You're always having to wipe the things down. You'd be wiping these down in the middle of the night, and all of a sudden it fires off on you, and it'd scare the hell out of you. About 2 in the morning when they had a reactor scram. Okay, we'll continue on. This isn't too boring, but it's what it is. We're just trying to documentate the plant, because pretty soon this will all be forgotten and gone. Okay, these pumps passed the dual check. They went to 102-inch lines. I had butterfly valves that came off. It fed a 44-inch line that went to the 182 building, the high lift pump house. In the high lift pump house, we had the high lift diesel pumps, which are part of the ECS cooling, but we're not addressing here. We had the diesel fire pump and electric fire pump. They were rated 110 PSI, 2,000 gallons a minute. There was a lot of backups on this, so it could, high pressure raw water pumps could also cover that. Everything had multiple backups. We had the low pressure raw water pump. They're 175 PSIG, 3950 gallons a minute. High pressure raw water pump, 200 PSI, 2650 GPM. And the big thing on this were the fog spray. They were GMC diesel engines, the 278A diesels. 2 of these ran. Normally they'd pull water off the low lift pumps. The ERW tank, emergency raw water tank, sat on here. This provided the water while these pumps got up and running. In 40 seconds they should be at full speed and pumping. It took maybe a minute for the water to get up here, so this provided water to the fog sprays until the low lifts would catch up. From the fog sprays, it went to an 8,000 gallon accumulator tank. It's just kind of a buffer. So if the fog spray nozzles tripped, you had water instantly while these diesels fired off. It took them about 40 seconds to get up to full speed. But this line was always charged, come off the high pressure raw water pumps. So there was always pressure on the fog spray. This is for ruptures, if you have a pipe break, major steam leak inside the containment. These would come on, knock down the steam. The other pumps provided by this was the coag pump, coagulator pumps. These were the feed to the filtered water plant. It went to the feed mix tank where alum was added and chlorine. And then it went to the coagulation basin. Basically the alum and the particulate would clump together, make particulate like snowflakes. You could see a lot of it fall out. They used to have paddles, and it's kind of an elaborate system where they tried to make good flock. Then the flock went to the filters. They added Separon, which helped a filter aid, helped the flock to stick to the filter media, which was anthrafelt. We did a video on the Wheeler false bottom filters a while back, and that's what these were. The fog spray we mentioned knocked down steam. High pressure raw water kept system pressurized. Low pressure raw water pumps provide cooling to the high pressure air compressors, high pressure injection pump coolers, mostly the fluid coupler and mechanical seals. And the spill cooler in 109 system where the spill water out of the reactor blowdown was cooled, and the 182 diesel jacket cooler. They had the same pumps, the same engines up there, the GMC 16278s ran the high lift pumps and fog spray. So you had 5 diesels downstairs. When they fired off, they got pretty loud. Anytime the reactor scrammed, all 5 would start. Then the high pressure raw water, water to the 105N rupture monitor. Rupture monitors looked at every tube for any fuel element failures, any of the cladding that was leaking. It was also the backup for the reactor thermal shield and control rod cooling. Filtered water was a normal water for that. Fire system pressurization, 105, 109 confinement fog sprays. So this was in the 182 building. It was your critical high lift pump building. The valving was really critical. Everything had to be perfect because if there's a reactor scram, diesels had to start, had to have the water flow path. There wasn't any room for error. Okay, this is the layout of the 109 building. We have the dump condensers we talked about, water coming into them. They sat right along the river side of the building. Back here were the primary coolant pump drive turbines. Surface condensers sat down in the basement. These were the steam generators. They sat back here in the 109 gallery. These walls are like 5 feet thick. They had really heavy doors on them. I don't know, they're probably 12 feet wide, fairly tall. They're about 5 foot thick of concrete line, so it took a lot of effort to get them to move, and once they started moving, it's hard to get them to stop. They're very well balanced. Some other items of interest: pressurizer for the primary coolant loop sat up here. So there's 16 dump condensers. They were cooled with river water. The drive turbine surface condensers and the lube oil cooler was cooled with river water. And the final item is the seal well. There are 2 lines coming out. You had the 108 inches off the dump condensers coming in. 66 was off the drive turbines. The purpose of this was to mix the water and try and minimize the thermal pollution from the plant out to the river. I believe they had really tight limits, like 2-degree rise or something. It was pretty low. This was an overflow flume just in case something plugged up, something happened, the water would still go. So they brought the two, and usually this water here was fairly cold. They weren't running the dump condensers. Had a little bit of steam in 4 of them just to keep them warm in case there was a reactor scram. So it mixed with this water here, and then it went out about to the middle of the river, so it spread out the heat load very well. And that pretty much concludes this section. Okay, this is the third and final section of this. We broke it into sections. It just seemed like it worked better because we have some drawings and stuff we're going to put in here. Downstream of the circulating raw water pumps, there's 202-inch lines. They fed up here to the 109 end building, which was the heat dissipation building. I came in and fed the dump condensers. There were 16 dump condensers. I think these are 20-inch lines that went to them. They're capable of getting rid of 13 million pounds of steam an hour. They were for, like we mentioned in the first one, for reactor scram or for startup. They maintained the pressure on the main steam header. Any extra steam was condensed and sent back in. Downstream of this, it fed the dump condensers and also went to the drive turbines, surface condensers. These were 9,100 horsepower steam turbines. There's 6 of them. You needed 5 to run. Condensed the steam for that. Also went on fed the 184N turbine generator surface condenser. This was a hydrogen-cooled generator, which you mentioned. This provided power to all the B-bus, all the even number pumps, basically. If you had 3 pumps, 1 would be A, 2 would be B, and 3 would be either A or B. You could select it. So this was a critical piece of equipment. If you lost outside power, like we said, there's enough steam, a thermal flywheel to keep this running until you get the boilers fired up and grab the load. I think you can run at least a half hour because the drive turbines would slow down and you had enough steam to keep everything going. In 184, there's also the service water pumps. They're just 350 gallons a minute, 100-foot head. They start at 60 PSI. They're just a backup filtered water, turbine generator, hydro cooler, air compressors, boiler feed water cooling pump. This had oil and mechanical seal cooling, flash tank cooling for the boilers, and sample cooling. So this was just kind of a backup off this. You had your main coagulator pumps. They put out 7,500 gallons a minute, 45-foot head. Like we said, these provided water to the coagulator mix tank, which chemicals are added, and that ran the filter plant. Over here, you also had water going to the graphite cooling, and this cooled the reactor thermal shields and control rod. Quite a few things were fed off of this, but these are in a cell in 109, the middle one. So this was the main part of the reactor cooling. The water out of this, you had 2 separate lines. The turbine generator surface condenser, 184, and the drive turbine come down one line, 66-inch line. Dump condensers went down another line, 108. These went to the seal well. From here is discharged to the river. Temperature limits were critical. So this was designed to minimize any water temperature excursions. We talked about seal wells in another video we did, so we won't cover much of that. We do have some drawings of this stuff, and it makes it a little bit more clear. And that concludes the raw water for 100N, just kind of a basic overview. We'll throw a few drawings in to make it a little bit clearer. But that's pretty much it. Thank you.